Okay, Assalamualaikum and hello everyone. So continuing to the last part of 4.2, which is to determine your molecular polarity. So molecular polarity or polarity of the molecule actually tells whether your molecule is polar or non-polar. So to have a polar object, it means your object has opposite ends. Like your magnet, you have north and south pole. Okay, so those are of opposite ends. Okay, so your molecule can be polar or non-polar. So how do we know the molecular polarity? It is actually prerequisite knowledge for you to predict the shape of your molecule. So from there you can actually apply new concepts to predict molecular polarity pula. Okay, so why is it important? This is important because the polarity of a solvent affects the nature of your compounds that can dissolve in it. If you recall, likes dissolve likes, okay, benda sama akan melarutkan benda yang sama. So what is this benda sama? For example, if you have polar solutes, okay, it will only dissolve in polar solvents. It will not dissolve in non-polar solvents. So when you're doing experiments, you need to, when you want to dissolve polar solutes, you must dissolve it in polar solvents so that your solids will dissolve lah. Okay, so this is kind of a basic thing that you will learn before you go into real chemistry labs. So another thing, okay, to show the polarity of your molecule is, let's say if you have water molecule, right? Okay, so your water molecule, okay, coming out of this tap right here, okay, and when you bring a charged comb, negatively charged comb with this negative charges within it, okay, your water will actually be attracted towards your comb. So why is that? It is because your water molecule is a polar molecule, so it has a bent shape. So here we can see that it is partially negative on one side right here and partially positive on the other side right at this end. Okay, so if you look here, okay, this is the partially negative side of your water molecule and this is the partially positive side of your water molecule. Okay, so that's why this part is attracted towards your negatively charged comb. Alright, so what does your molecular polarity depend on? It depends on two things, which is the shape of your molecule and the electronegativity of the bonded atoms. So you will be analyzing your bonds whether or not they are polar. Okay, adakah dia polar bond atau non-polar bond. Okay, so to know the polarity of your molecule, we must assess the polarity of its bonds. So we are going to look at covalent bonds because covalent bonds, your electrons are shared between your atoms. So that means you will have a partially positive end of the bond and partially negative end of your bond. Why not ionic bond? Your ionic bond, okay, is between definitely opposite charges. That means it is between positive and negative, fully positive and fully negative. So the charges are already definite. Okay, so we're going to talk about covalent bonds because they will share the electrons, okay, between that bond. So your covalent bond, it can be polar or non-polar. So a non-polar bond, if you have a non-polar bond or all your bonds are non-polar within that molecule, you will definitely have a non-polar molecule. But if you have at least a polar bond, then that means you may have a polar molecule. Okay, tak semestinya awak akan dapat polar molecule kalau awak ada polar bond. So boleh jadi awak dapat non-polar molecule juga. Okay, because it will depend on the shape of your molecule and the electronegativity between your atoms. Okay, so let's look at non-polar bonds first. So non-polar bonds, it involves two atoms of the same electronegativity, meaning selalunya, usually it is between two similar atoms lah, atom yang sama. Why is that so? Because when you have atoms of the same electronegativity, that means the bonding electrons, okay, within that bond are shared equally between your two atoms. So let's say if you have chlorine here, okay, chlorine molecule, okay, both atoms are Cl. So that means they are the same atom of similar electronegativity. Therefore, the electron density will be shared equally between the two atoms. If you look at this arrow is equal and it is pulling towards opposite sides, right? So this will give your electron density will be distributed equally, okay, among these two atoms. Therefore, this bond is a non-polar bond. Okay? Okay. So next we have our polar covalent bond. Our polar covalent bond is formed when the bonding pair electrons are not equally shared. So this will occur between atoms of different electronegativity. Therefore, different atoms. Okay. So the atom with the greater electronegativity will pull the electron pair closer towards itself. Okay, this is chapter 3, recall. This forms a polar covalent bond. So if you look on your right, we have HCl. So obviously hydrogen is less electronegative compared to chlorine. Okay, chlorine will actually pull more of the electron density towards itself compared to hydrogen. Okay, so in your polar covalent bond, the bonding electrons, okay, are shared unequally between the two atoms. Therefore, you will have partial charges. So partial charges are represented by this delta negative. So this is partially negative charge, and delta positive, your partially positive charge. Okay. So for HCl, okay, for polar covalent bond, if they are different atoms, okay, that means that the atoms have difference in electronegativity. Okay, the more electronegative atom will have higher electron density, or pull the electron density closer to itself. So therefore, the bond will be a polar bond. Okay, so let's look at HCl. Okay, with more explanation. Okay, you can see here, okay, this electron cloud is much more bigger on chlorine side, right, compared to hydrogen. So that is representing the electron density. So right here is the region of higher electron density because chlorine is more electronegative. Therefore, it is the partially negative side. Okay, we'll have a partially negative sign there, and this one will be delta plus, partially positive. Okay, so what is this purple arrow here? So this is actually called your bond dipole. So bond dipole, okay, you will show it on your bonds. Okay, how? It is from delta positive pointing towards delta negative. Okay, so this bond dipole will show the shift of your electron density lah. Okay, mana yang lebih electronegative, that atom will have the delta negative. That means the arrow will point towards that side. Alright, so since this is delta positive, so this plus end will be on that side lah. Okay, macam tu je. So your bond dipole is actually a vector quantity. That means it will have both magnitude and direction. So magnitude ni depends on what? It will depend on the electronegativity difference between your two atoms in that bond, and direction will be depending on where is your delta positive and where is your delta negative. Okay, alright. So magnitude maksudnya betapa besar lah awak punya berapa besar awak punya arrow tu. Kalau dia punya electronegativity difference is small, therefore the arrow is smaller, okay, compared to bonds involving atoms of larger electronegativity difference. Okay, so how do we measure our polarity of a bond? So you will use this term called dipole moment, okay, represented by mu. So mu will equal to the magnitude of your charge times the distance between your charges. Okay, it will be in debye units. So a polar molecule will have a dipole moment, meaning that your mu will have value. That means that your mu is not equal to 0. So you don't have to tell the exact dipole moment, okay, when you are explaining, unless you have this tool, okay, but in most cases you don't need to, okay. So if you have a non-polar molecule, that means you have no dipole moment, meaning your mu will equal to 0. Okay? So when does your mu equals to 0? It occurs when the bond dipole or resultant dipole counterbalance or cancel out each other. So that means, let's say if you have carbon dioxide, okay, it is a linear molecule. If you put here your partial charges, okay, you know that oxygen is more electronegative than carbon, and the next step you will draw your bond dipole, okay, daripada partially positive to partially negative, okay, from partially positive to partially negative. You can see that the magnitude of your bond dipole is the same, but they are pointing at opposite ends, right? Opposite direction. That means your bond dipoles, okay, will cancel out each other. Therefore, your resultant dipole is 0. Therefore, your mu will be 0. That means you have a non-polar molecule for carbon dioxide. So let's say if we have water, okay, so water is actually a polar molecule. So why is it polar? So if you look at the shape of water molecule, it is a band shape. Okay, so first you're going to put your partial positive and partial negative. So oxygen is more electronegative, so it has delta negative. So hydrogen will have delta positive sign. So next step, you're going to draw your bond dipole arrow. Okay, daripada positive pointing to its negative. Okay, so you have two arrows since you have two bonds. Okay, so from those two arrows, we are going to look at the resultant dipole. Okay, if we put them together, we add them together, the resultant dipole will be pointing this way, right? Towards one direction. So this means that if you have resultant dipole, you will have a dipole moment. That means your mu will not equal to 0. If your mu is not equal to 0, that means you have a polar molecule. Okay? Maksudnya, the electron density within that molecule is not equally distributed. Ada part yang partially positive, ada part yang partially negative. Okay? So, that's why water is a polar molecule. Okay, so your molecules, it can exist as diatomic or polyatomic molecule. So for diatomic molecule, the atoms concerned could be of same or different electronegativity. So since you only have 2 atoms kan, diatomic molecule, we are going to look at the difference in electronegativity je lah. Okay, sebab kita ada satu je bond. So, let's say if your diatomic molecule has the same element like nitrogen molecule, chlorine molecule, okay, same atoms, okay. So that means that your bond here, your molecule here, diatomic molecule, does not have bond dipole, okay. Sebab the electron density is equally distributed within that molecule. So therefore, you will form non-polar molecules. Same case as chlorine, same case as hydrogen molecule, hydrogen gas molecule. So, if your diatomic molecule has different elements, therefore it will have difference in electronegativity. So that means your diatomic molecule of different elements will have bond dipole. So in this case, between hydrogen and fluorine, fluorine is more electronegative. That means that your bond dipole will be like this towards fluorine. So fluorine will be the higher region of electron density. Okay. So that means that your mu will not be equal to 0 because your molecules are polar. Alright. Same case as NO. Okay. So this is the Lewis structure for NO. So between nitrogen and oxygen. Okay. Oxygen is more electronegative because it's on group 16. This is in group 15. Okay. So your bond dipole will look like so. Since this is the partial positive and partially negative sides, okay, so therefore NO is a polar molecule. Alright, those are diatomic molecules, but in your exams it won't be as simple as that. Okay, they like to ask you of polyatomic molecules. So polyatomic molecules meaning you have more than 2 atoms. So if you have more than 2 atoms, that means that you have more than 1 bond, right? So you will have at least 2 bonds. So that means to determine the dipole moment for polyatomic molecules, you must look at the polarity of your bonds, okay? Your bond dipoles, draw them, okay? And the molecular geometry, okay? Maksudnya shape of your molecule. So these are the 2 things that will determine the polarity of polyatomic molecule. So even if the molecule has polar bonds, okay, semua polar bonds, the molecules will not necessarily have a dipole moment. Samalah maksud dengan yang ni. So if you have at least a polar bond, your molecule may or may not be a your molecule may be polar molecule or non-polar molecule. Okay, so you have to analyze. Okay, how do we do that? We will be using these 7 steps to determine the polarity of our molecule. So don't be afraid because the first 3 steps are actually something you are supposed to have learned from the previous video where you already predict the correct molecular shape. Okay, so once you have the molecular shape, okay, you're going to draw your respective bond dipoles. Okay, for each bond, you are going to draw the bond dipole arrow. Okay, and then from there, you are going to find the resultant dipole. Maksudnya nak tengok they cancel out each other or not. So if it doesn't cancel out each other, to which side does it? So that means it has a dipole moment or not. Okay. So after that, you can state the dipole moment, whether it is mu equals to 0 or mu is not equals to 0. And from there, you can know the polarity of your molecule. So if mu is equals to 0, that means that you will form a non-polar molecule. If mu is not equal to 0, then you will form a polar molecule. Okay, maksudnya electron density within that molecule is unequally distributed. Dia ada part partially positive, the other part partially negative. So the partially negative part, okay, is the region of high electron density, yang banyak elektron. Okay, so let's do this example. Okay, the question asks you to determine the polarity of the following molecules. So the first question is CO2. So let's look at CO2. Okay, so here we have our carbon dioxide molecule. So first we're going to draw out the Lewis structure. So once you have the Lewis structure, you are going to determine the class of molecule. It will be AB2, okay, because you have your central atom and two terminal atoms, okay, because you have at your central atom you have 1, 2 bonds, okay, two atoms. B2, no lone pair. So that means that CO2 is a linear shaped molecule. Okay, so draw out the linear shaped molecule now. Okay, ini adalah Lewis structure, ini adalah shape of molecule. Alright, and now we are going to determine who is more electronegative. So between carbon and oxygen, okay, oxygen is more electronegative. So that means oxygen will bear the partially negative charge, okay, while carbon will bear the partially positive charge. Next step, you are going to draw your bond dipole, show your bond dipole. So since this is delta positive, your arrow will start from here and point towards delta negative. So this one pun sama, okay, towards oxygen. Okay, so when you analyze, okay, the bond dipoles have the same magnitude because this is CO bond and this one is also CO bond, so same magnitude but pointing at opposite directions. Okay, so the resultant dipole, okay, if you draw it out, okay, will actually cancel out each other. Okay, so the bond dipoles, the resultant bond dipoles will cancel out each other. Therefore, resultant bond dipoles will cancel out each other. Okay, therefore your mu is not equal, your mu is equal to 0. Therefore you will form a non-polar molecule. Okay, so CO2 is a non-polar molecule. Alright, so next we're going to do for CCl4. So start with your Lewis structure and then determine the class. From the class you can determine the molecular shape. Okay, so draw out your molecule shape. Okay, so it's tetrahedral. And now we are going to determine who is more electronegative, who is the less electronegative. So between carbon and chlorine, chlorine is obviously more electronegative, therefore it will bear the partially negative charge, while carbon will bear the partially positive charge. Okay, next step is for you to draw the arrows from carbon towards chlorine. Okay, so since they are all CCl bonds, right? The magnitude of your CCl bonds will all be the same. Okay, all these arrows, each of these arrow will have equal magnitude. Okay, and if you imagine, right, okay, your bond dipoles, okay, it is all pointing out, okay, from one center. Okay, so that means your resultant bond dipole will cancel out each other. So your resultant dipole moment will cancel out each other. Okay, so that is your reason resultant dipole moment will cancel out each other. Okay, your bond dipoles cancel out each other. So you can conclude that your mu is equal to 0. Therefore, CCl4 is a non-polar molecule. Okay. So these bonds are polar. Okay, semua polar bonds. Tapi because the shape is tetrahedral, your arrows are all pulling out from carbon, okay, pointing towards chlorine. So you can imagine that the force is cancelled out by each other. Alright, so therefore mu is equal to 0 and so on. Okay, next example is NH3. So NH3, okay, if you look closely at your Lewis structure, you can see that at your central atom nitrogen, you have a lone pair and 3 bonds, right? So the class is AB3E and the shape of your molecule will be trigonal pyramidal shape. Okay, so ini awak kena ingat lah macam mana nak lukis that shape. Okay, so this is the shape of trigonal pyramidal, right? So next, you're going to determine who is more electronegative, hydrogen or nitrogen. So hydrogen is obviously less electronegative because it's in group 1. And nitrogen is in group 15, so it's more electronegative lah. Okay, so it will bear the partial negative. This one partial positive, partial positive, partial positive. So your bond dipole arrows will point towards nitrogen. Okay, so draw those out. Alright. Okay, and now we are going to analyze the resultant dipole moment. Okay, if you look, okay, since your arrows are all pointing towards nitrogen, okay, upwards, okay, so your resultant dipole moment will be pointing towards this direction. Betul tak? So because of this lone pair, alright, because of this shape, okay, your NH3 molecule will have a dipole moment. Okay, so mu is not equal to 0 because the bond dipoles do not cancel out each other. Alright, so therefore your NH3 molecule is a polar molecule. Okay, so next 2 examples are cis and trans molecules. Okay, so these 2 molecules have 6 bonds around itself, so they are both octahedral shape, but because of the difference of placements of chlorine, okay, for cis your chlorine is on the same side, and for trans your chlorine is on opposite sides. Okay, this will give different polarity lah for your molecule. Okay, so you have to check your bond dipoles and resultant dipole moment. Okay, so saya terus lukis the molecular shape. Alright, you should do it step by step so that you do not miss anything. Okay, so I'm going to first put my partial positive and partial negative. So between fluorine and sulfur, fluorine is more negative, electronegative. So sulfur will be positive lah, fluorine negative. Okay, so I'm going to put that. Alright. Okay, chlorine pun is more electronegative compared to sulfur. However, the bonds, okay, SF and SCl, okay, will be different, will have difference in electronegativity. Okay, will have different values, different magnitudes for their dipole moment. Okay, So this bond is more polar than this bond because fluorine is much more electronegative compared to chlorine. Okay, therefore your bond dipole for this bond will be much bigger than the bond dipole for this bond. Okay, so the size of your arrow will be different. Okay, since they are different bonds. Okay, so please take note of that. Right, so ini saya letak delta negatif dia kecil sikit. Okay, supaya awak ingat yang chlorine is less electronegative than fluorine. Okay, and then when you want to draw the arrow for SF bond and SCl bond, okay, you have to make sure that they are different lah. Okay, so ini ambil tebal macam ni. Okay, nak menunjukkan yang awak punya SF bonds are much more bigger than SCl bond. Okay, okay, alright. So imagine, okay, the shape of your octahedral shape. So you have atas, bawah. So depan, belakang, depan, belakang, depan. Okay, imagine, okay, imagine the shape is like that. But right here, okay, the arrow, the bond dipole is much bigger, pulling out, pulling out, pulling out, pulling out. Maksudnya ni kecil je. Okay, so in this case, your resultant bond dipole or resultant dipole moment, okay, will be towards this side. Okay, because your fluorines are much more electronegative compared to your chlorine. Okay, so here you can conclude that your cis SF4Cl2 is a polar molecule. Okay, alright, next our trans SF4Cl2. Okay, so in this case pula, your chlorines are on opposite sides, atas dan bawah. Okay, imagine this is your equatorial part, equatorial position. This is your axial position. Okay, so ini adalah atas plane, okay, axial, and this is bawah plane, axial. Alright, so if you draw your bond dipoles, okay, ni. This one will be here. Astaga, tebal. Tak apa. Asalkan kita nampak. Okay, macam ni. Okay, if you imagine, right? Okay, sekarang berbeza because our chlorine is on axial positions. So this bond will cancel out with this bond dipole will cancel out with this bond dipole. Okay, so kat sini akan hilang this bond dipoles. And here pula, all at equatorial positions, okay, all equal magnitude, pulling out, okay, all four of these bond dipoles will cancel out each other, right? So that means your trans SF4Cl2 molecule is a non-polar molecule, okay, because the resultant dipole moment is cancelled out by each other, meaning your mu is equal to 0. Alright? Okay, so that's the last example. Okay, here's just a summary for bond polarity, or sorry, molecular polarity. So the factors affecting the polarity of your molecules will be molecular shape and electronegativity of your bonded atoms. Okay, so we will continue with 4.3 in the next video. Thank you.